The notable James Webb Space Telescope has been standing out as truly newsworthy since its send-off in 2021. This cutting-edge innovation has turned into an instrumental apparatus in cosmology, giving new bits of knowledge into the intriguing beginnings of the universe, the development of worlds, and the quest for life beyond our solar system. However, the latest revelation uncovered something frightening that could change our whole view of the universe as we know it. Fit to be blown away, the James Webb Telescope has recently captured a chilling new picture of the very edge of the universe. What has NASA's freshest telescope found, and how does it change stargazing as we know it? Stay tuned, and let's figure out in this video. Heading out to faraway planets has continuously been a dream for humans. Thanks to the powerful James Webb Space Telescope, we're one step closer to this dream. Although more than 3,000 exoplanets have been found, a large portion of them have only been identified through a dip in light caused by their movement in front of their host star. Webb changed the game by capturing the first direct image of an exoplanet in September 2021. This significant event marked a giant leap forward in stargazing. The exoplanet, named HIP 65426b, found in 2017, required utilizing 2 of Webb's cameras, a few filters, and the telescope's coronagraph to shut out the focal star's light and get a clear view of the planet's features. This epic gas giant turned out to be around 12 times the size of Jupiter and several times further away from its star than Earth is from the Sun. It was truly a remarkable find. The universe is infinitely dazzling and baffling, filled with mysteries and wonders surpassing our most stunning minds. From the vast field of the universe to the smallest subatomic particles, each corner holds secrets ready to be uncovered. Despite all our advances in science and technology, there is still so much we have hardly any familiarity with about what lies beyond the unmapped. The advent of the James Webb Telescope changed that. It has helped disentangle some of the most confusing questions and answered some of the most perplexing inquiries that have long troubled scientists. One such baffling question lies at the edge of the universe. The James Webb Space Telescope first amazed the world in July 2022 when NASA released the telescope's first new pictures of star systems and an exoplanet. Webb's picture provided new insights into how cosmic interactions may have driven galaxy formation in the early universe. The first image released showed a collection of galaxy clusters called SMACS 0723. These galaxy clusters act as a magnifying glass, a phenomenon known as gravitational lensing. Gravitational lensing happens when the gravity of a massive object, such as a galaxy cluster, bends the light from objects behind it, causing them to appear larger and brighter than they really are. The gravitational lensing effect created by SMACS 0723 allowed the James Webb Telescope to capture its most detailed deep field view, including ancient and faint galaxies that had never been seen before. This was a significant achievement as it demonstrated Webb's ability to capture images of distant and faint objects once beyond the reach of other telescopes. The image of SMACS 0723 was taken by the near-infrared camera NIRCam, which captured images at various wavelengths of light over 12.5 hours. This allowed the telescope to take a detailed and comprehensive view of the galaxy cluster as it appeared 4.6 billion years ago. The first release from NASA's James Webb Space Telescope included images of celestial objects such as the Carina Nebula, the Southern Ring Nebula, Stephan's Quintet, and WASP 96b, an exoplanet found 1,150 light-years away from Earth. The spectrum captured by Webb of WASP 96b is the most detailed spectrum of an exoplanet to date. It covers various wavelengths of light, providing intriguing information about the planet and its atmosphere. The spectrum shows evidence of water vapor and clouds in the planet's atmosphere, showcasing Webb's ability to analyze atmospheres many light-years away. The Southern Ring Nebula is a vast planetary nebula found 2,000 light-years from Earth, containing an expanding shell of gas around a dying star. Webb helped uncover previously hidden details about the nebula, including the shell of gas and dust produced by the dying star, and how the star's shape influenced the gas and dust cloud. The Southern Ring Nebula was previously considered a simple dying star shedding its outer layers, but the recently released image from the Webb telescope revealed that a third star might be involved in the formation of the amorphous structure. The mid-infrared instrument, MIRI, showed that the white dwarf star was not invisible but glowing red, surrounded by a cloud of cool gas, leading researchers to believe another star exists there. There are intriguing shells around the outer edges of the cloud that a third star might have caused, suggesting that all the gas and dust might have originated from that one star. According to Joel Kastner, an astronomer at the Rochester Institute of Technology in New York and one of the study's co-authors, the companion stars are arranged in specific directions. Stephan's quintet is a compact galaxy group found 290 million light-years away in the constellation Pegasus. 4 of the 5 galaxies in the group are engaged in a vast dance of repeated close encounters. Finally, the Carina Nebula is a stellar nursery found 7,600 light-years from Earth, where stars are born. Webb's image reveals previously invisible regions of star birth within the nebula. The James Webb Space Telescope, the newest addition to our stargazing arsenal, identified an exoplanet unlike any other. This celestial object turned out to be a brown dwarf, larger than a planet but not quite large enough to be a star. The observations made by this extraordinary telescope have uncovered some fascinating facts about this celestial body. The brown dwarf, known as VHS 1256b, emits a faint reddish glow due to the modified form of fusion that occurs in massive objects but is too small for hydrogen fusion. Even more notably, Webb found silicate clouds surrounding this brown dwarf, which had never been seen before in such an object. The interest doesn't stop there. The exoplanet is relatively young and small for its kind. Despite its modest size, there is much to learn from it. Webb also identified various atmospheric compounds, including water, methane, carbon dioxide, and potassium. The study of this discovery has suggested that there is violent vertical mixing in the exoplanet's atmosphere, which means that carbon dioxide from deep within is being brought up to mix with methane high in the atmosphere. What a bizarre and wondrous world we live in. Have you ever heard of the Ghost Nebula? It might be tricky in the night sky, but its brightness dazzles when captured in infrared by the James Webb Space Telescope. By combining images from the Hubble and Webb telescopes, scientists have created a mesmerizing composite image that highlights the nebula's twisting structure and filament-like patterns of heat-emitting dust and gas emanating from its brilliant center. This captivating image is part of a larger internal project called Teeth, which uses Webb, Hubble, and several ground-based telescopes to capture 19 nearby star-forming regions in the infrared. By utilizing Webb's ability to see through dust and gas, astronomers hope to solve the mysteries of star formation and interstellar space. With the capability to accurately measure the masses and ages of star clusters, pinpoint star-forming regions, and investigate the nature of dust in space. The addition of crystal-clear Webb observations promises to change our understanding of these fascinating worlds. In February this year, the Webb telescope made a groundbreaking cosmic revelation in the distant universe. It answered the age-old question that has puzzled people for ages. What is at the edge of the universe? Astronomers used the James Webb Space Telescope to observe 6 massive galaxies that existed between 500 million and 700 million years after the Big Bang. These galaxies were surprising because they were as developed as our own, and it was previously believed that only small, young galaxies existed at that time. The galaxies appeared as large spots of light, and the team was astonished to see them. The amount of mass found indicates that the known mass and stars at this period of our universe is several times greater than previously thought. These objects are far more massive than anyone anticipated, said Joel Rica, assistant professor of astronomy and astrophysics at Penn State University. We expected only to find small, young galaxies at this time, but we found galaxies as mature as our own in what was previously thought to be the first light of the universe. Researchers used the Webb telescope to observe the universe in infrared light, which is invisible to the naked eye and capable of detecting faint light from ancient stars and galaxies. By looking into the distant universe, the observatory can see back in time up to around 13.5 billion years. The enormous galaxies identified by the Webb telescope challenge current theories of early universe formation, leading scientists to reconsider their understanding of how galaxies evolved. The team, led by Rica, was astonished to see these galaxies appear as bright spots of light in the telescope's first high-resolution images. They were so bewildered that they initially thought they had misinterpreted the data. However, after analyzing the data further, they found that the galaxies were real and much more substantial than they had expected. To determine why these galaxies evolved so quickly, the team plans to take a spectrum image of the galaxies, which involves splitting light into different wavelengths to identify various components and determine the actual distance of the galaxies. The spectroscopy data would provide a more detailed look at the galaxies and their sheer size. Rika emphasized the importance of keeping an open mind about what they see, as this is their first glimpse back this far into the universe. While the data suggests that the objects are likely galaxies, there is a possibility that some